Good afternoon, and thank you for your time today. My name is Dave Allen, and I'm the Director of Business Development for Stepan Company. Many of you might be familiar with Stepan Company as a supplier of coformulants to the agricultural market. But today, I'm going to be talking to you about an exciting new development, and that's rhamnolipids as a biofungicide. Let's spend a few moments discussing the rhamnolipid manufacturing process. Rhamnolipids are produced via fermentation using the organism Pseudomonas aeruginosus. The product of the fermentation is a mixture of biosurfactant structures which contain one or more rhamnose heads and one or more hydroxy fatty acid tails. It is a mixture of these conjugars, as they're commonly called, that make up the biosurfactant rhamnolipid. Earlier this year, Stepan acquired process technology and intellectual property for rhamnolipid production. We view this class of biosurfactants highly favorably because of the biodegradability and low environmental and human tox profiles. In the next few slides, I'll be discussing the antifungal properties of this interesting class of compounds. We have interest in using rhamnolipids across a broad range of markets and applications. Primarily, I'm going to be talking about the agricultural space today and use as a biofungicide. However, there are many reports in peer-reviewed journals for using rhamnolipids in soil remediation and also in applications to improve soil health. At a high level, rhamnolipids has a dual mode of action. On one hand, it disrupts cell membranes of zoospores via physiochemical surfactant action. On another hand, it has the ability to stimulate defense and protection mechanisms in the plant. As a fungicide, the single known product on the market today is registered by a company called Geneel Biosurfactants, and the product is called Zonix. As you can see from the Zonix label, there's a wide variety of fruit, vegetable, and ornamental crops that can be treated for zoosporic fungal diseases. The physiochemical properties of rhamnolipids are interesting. They can be produced in a variety of concentrations, are completely miscible with water, have low odor, and a mild pH. Looking at the acute toxicology, you can see from this chart acute oral and inhalation and primary skin irritation are all category 4, while the only signal word on the label is driven by the eye irritation, which is considered category 3 or danger signal word. From a crop and disease target perspective, we feel as though greenhouse crops is a logical starting point for using rhamnolipids given their activity on relevant pests as shown in the table, overlaid with some of the human health and environmental safety profiles that I mentioned earlier. Our plans for future development for rhamnolipids are shown on this slide. As I mentioned before, greenhouse crops seem like the logical place to start given the pathogen activity. We feel that the compelling attributes of application flexibility and compatibility, along with low residue, make that the ideal starting point. However, we see some opportunities for enhancement and advancement as it relates to broadening the use and also providing enhanced application properties, IPM opportunities, and cost-benefit optimization, which can be achieved through formulation enhancements or with combination of other active ingredients. So in closing, I want to thank you for your time today. I hope you found this information insightful and interesting, and we look forward to partnering with collaborators to bring this technology to the market. Thank you.